Hi and welcome to the 20th edition of Physics 9. This is Sir CJ. And we have the following parts for this session. The first part is problem solving, independent problem solving na ito. This is about conservation of momentum. So you will be in charge now of identifying what kind of collision happened, and you will be deciding on what kind of say a formula you're going to use. It's gonna happen twice. So we have the problem number one here and the problem number one too. And then we will be sort of summing up so far what we learned through concept mapping of impulse momentum theorem. Okay, so the learning competencies for this session are the following pa rin. Infer that the total momentum before and after collision is equal. And then you should examine the effects and predict causes of collision-related damages or injuries. Remember that this is based on the 7E based self-learning module in Science 9 which I wrote for my master's degree, particularly found in Unit 4, book number 20, pages 23 to 26. Okay, so let's begin with the first problem. I hope that you are ready with your sheet of paper, your calculator, and your pen. So in this problem, Anthony and Gerald are playing with two metallic balls that are 120 kilograms and 240 kilograms heavy, respectively. Anthony's 120 kilogram ball is moving with a velocity of 32 meters per second towards the right, while Gerald's 240 kilogram ball is moving at 25 centimeters per second. Actually, if I read this meters, I'm sorry, that's centimeters per second, towards the same direction. So it's also moving towards the right. Now, what will be the final velocity of Anthony and Gerald's balls if they get stuck together and have a common velocity of 28.9 centimeters per second, assuming that they are, sticky, okay, and that assuming that they stuck together and that they moved with the same velocity. Okay, so it's now the time for you to identify what kind of collision this is, decide what formula to use, and of course, show your diagram and your solution as well as your answer. You may now start solving. You may pause this video. Once you're through, okay, let's now proceed with the answers. So the diagram should look like this. Okay. Now, let us say that this is the diagram, pero let us look at how it moves. Do you think it's moving towards the left? Again, do you think it's moving towards the left? No. According to the problem, it should move towards the right. So what should you do with this arrow? Okay, so move it towards the right. Very good. Now, for the answers, your answer should be the following. So the initial total momentum, should be equal to 9,840 kilograms centimeters per second. And the final total momentum should be 10,404 kilograms centimeters per second. I would like to correct that. If you're truly listening to these video lessons, I hope that you're picking up on these these trick corrections. Okay, so this is kilograms centimeters per second. So the system is traveling towards the right, not towards the left. Okay, yes, we were correcting this one. Very good. I hope that you're keeping an examining and scrutinizing eye, because we will be seeing more errors soon, and we will be correcting them one by one. Let us now proceed with the second problem, independent problem solving. On Saturday nights, Neil Anthony loves playing billiards with Franco in their community place called Wishing Well. In one instance, Neil hit the cue ball to move at 1.5 meters per second, which hit an 8 ball that was originally at rest. So take note that should be 0 meter per second. The cue ball stopped completely upon hitting the 8 ball, but the 8 ball was sent moving towards the same direction, same velocity. Note that the standard mass of a billiard ball is 0.17 kilogram. Now, illustrate your solution through a diagram and then show your solution. Of course, make it complete, decide what formula to use, and then box your final answers. You may now begin answering this problem. Are you through? Okay, if you are, let us now look at the diagram. So, in this diagram, the first mass, which is the blue one, is representing the cue ball. Okay, and then the second one naman is the eighth ball that is now set running towards the right. Again, set running towards the right. The absence of an arrow for M1 means what? Very good. It means it is at rest. For the answers, your initial and your final momentums should be as follows. So it should be equal 0.255 kilogram meters per second. And yeah, we can say that the momentum was conserved. Did you get the correct answers? Okay, let's now proceed to the last part of this session, concept mapping on the impulse momentum theorem. So in this particular concept map, you start with this theorem, and then it shows that a large impulse can cause a great blank in objects which takes place during blank, which may be blank, inelastic, and blank. Okay, so take your time now to complete this concept map. If you're through, let us now proceed with the answer for this concept map, shall we? Are you ready? Okay, so the answers are as follows. Impulse momentum theorem shows that a large impulse can cause a great change in momentum in objects which takes place during collision that may be elastic, inelastic, and perfectly inelastic. Did you get all of the answers correctly? Check your work. That ends the 20th edition of Physics 9. This is Sir CJ, and in this edition of Physics 9, we were able to cover the following sessions: gather information on problem solving numbers 1 and 2, and then gather information concept mapping on the impulse momentum theorem. The learning competencies that we covered are as follows: infer that the total momentum before and after collision is equal, and examine the effects and predict causes of collision related damages or injuries. Remember that this was based on the 7E based self-learning module in Science 9, which I wrote, and particularly you'll find these parts on Unit 4, Book 20, pages 23 to 26. I hope that I will see you in the next video lesson. Have a good day.